All right, let's see if we can't do our Unit E5, Day 11 assignment. And so when you're doing this, you should look at that pumpkin. Okay, there she is. There she goes. I don't know what she's about to do. She's about to go do something. Okay. Anyway, I love sitting here, being able to sit with my dogs. All right, so here we have, now notice what I have up top is the binomial and geometric formulas, because I'm going to be using both of those for this assignment. And so I'm going to scoot that over there so we can see both of those. So remember, let's recall when you would use which. You would use binomial if it's out of a set number. You would use geometric if you're going until a success at a particular place. Okay, going until the first success is the geometric. Out of a set number of trials is binomial. Now, here, this first page is about the number of senior athletes who graduate. So, and the probability that it's a senior athlete who graduates is 72%. All right, so they here tell me about 50 seniors. So that's a set number of seniors. So the total N is 50. So A says we want exactly 40. So that's an exact amount of X. So that is just like what we did a couple days ago, where we just had exactly 40, and we would put that into Desmos this way, where we had a binomial distribution of 50 with 0.72 probability, and then the successes we want are from 40 to 40 because we just want exactly 40. All right, next we are then going to start now accumulating successes. So here we have 35 or 36. Well, it's easy enough on this one, so we want the successes to be 35 or 36. So we add those two separate sections together. So notice here is let me get over here and get my writing tool. So we've got the, right here, we've got the 35 successes, okay, which gave me 15 failures, so that's my plus, and then I have 36 successes, so 36 successes, which was 14 failures. So what I did was, you can see that I was able to go in here to my binomial distribution over here, and I did 35 to 36, and it goes ahead and adds those two probabilities together. So then we have got the 0.24 13. All right, next we have got an accumulation, but we are accumulating a whole lot that I do not want to have to write out all of those. So I want to use this notation that I want all the x's less than 38. So I do not want 38, I want 37 and less. So notice whenever I did this here, I went 37 and less than or equal to 37. So then when I showed my work and I wrote in the formula, since I was going to be using multiple x's, I left that as a variable because that value varies. So I want all the x's less than 38, and notice I leave x in the formula. So I do the formula as it shows me up above, but I leave it with the x's in there. So I leave this, and I leave that x, and I leave that x. The rest of them I plug in. All right, so when I did that, less than or equal to 37, it gave me 0.6749. Now this one is 40 or more. So that means I do want greater than or equal to 40. So I'm going to go to the right, greater than or equal to 40. And this one looks, as far as this part and this part, they're identical. That's why this beginning is so important, because that specifies which x's I'm going to be plugging in to that formula. All right, but when we get to part E, we have geometric, because it says, what's the probability that the first success we come to is the fifth So that now is a geometric probability where we've got 4 failures and then the 5th one is a success. All right, and then here is a geometric, but it is accumulating. So you can do this one of 3 ways. You can do this accumulation less than or equal to 8 because we want the first one that we come to be within the first 8. So I did a geometric distribution, and then I did less than or equal to 8. All right? You could also just write all those sections out, or do the 1 minus the opposite. 1 minus the opposite of what you want. So if I want at least one of them being, one of the 8 being an athlete, then I'll do 1 minus all 8 of them are not a senior athlete who graduates. Okay, now this page is all about the number of UPS trucks that pass inspection. So that's our variable that we're talking about. And then our for a lot of these, we're talking about out of 25 trucks. So that's N is 25. And depending on the problem, we have different numbers of successes. This first one is just exactly 10. So notice how I computed that. It's between 10 and 10. Okay? The next one is more than 20. So that is purely greater than 20. That's important. Look at how this is. You do not put a 20 right here because this symbol is greater than or equal to. So that's greater than or equal to 21. Okay? Important that you put that in there properly. All right, the next one is another exactly 2. So that's nice, another exactly 2. Ooh, but the interesting thing is it's talking about exactly 2 fail inspection. So that means our success is the failing probability, not the passing probability. So you have to watch that very carefully. Now we have between, now it does say and including, so it's 20 up to 24. So we're going to go ahead and have these are equal to 20 and up to equal to 24. So that makes it easy here now, but wait, we are talking about passing. So once again, my success is this pass rate here. All right, but now on part E, we have a geometric because it says the first truck to pass is before the 5th. So to me, that means it's got to be the 4th and earlier. The first success is less than or equal to 4. So you can do that way. You could write them all out separately, or 1 minus the opposite of what you want. And I want all 4 passing. So the opposite of what I want is 1 minus 4 failing. All right, and then these last two, well, not H, but F and G have to do with what you are expecting. And expected value is the mean. Expected value is the mean. Expected value is the mean. So now the key is, which is, am I dealing with? A geometric expected value or a binomial expected value? So how do you tell the difference there? Well, that's based on the question. If it's going until the first success, if I want to know how many do I expect until the first success, that's your geometric. So that would be this geometric formulas. 1 over the 0.92 because we're talking about a pass as the success. And then you have that standard deviation formula. But if I talk about what's the expected number out of 25, so that's out of a set number of trucks, how many do you expect to pass? So that's my success is a pass. So that's out of the N is 25. So I had to put that in there. And I'm using the binomial formulas for mean and standard deviation, not geometric. All right. And then our last one, was using that mean and standard deviation, and it says, what would be an unusually low number of trucks to pass inspection? Well, an unusually low number of trucks would be an outlier amount of trucks. So do you remember that from a while back? Outlier is more than 2 standard deviations below the mean. Now, it does ask specifically how many trucks, not on average, how do you expect? So if it asks me specifically how many trucks, what would be an unusually low number of trucks? So make sure that you are in an actual realistic number of trucks, not a decimal. Decimals are okay with averages, but not when it's actual number of trucks. So I've got the 2 standard deviations. So I did 23 minus 2 standard deviations. Of course, I'm using the mean and standard deviation from part G. So that's a fence. So there's my outlier fence is at 20.28. So how many trucks is the outlier? 21 is inside the fence, not an outlier. 20 and below. So 20 trucks or less would be an unusually low amount to pass inspection and make me think there's something wrong happening at that UPS station. We are not having good maintenance, that kind of thing, something or other. We are having too few pass inspection. All right, and so then here is our last page where we are dealing with X is the number of people with type B blood. So that probability of getting a type B blood person was 0.11. So how many do you expect to check until you get the first type B blood? That's a geometric probability until the first occurs. Geometric mean formula. Geometric standard deviation formula with that 0.11 plugged in. Now here is the 10th is the first donor with type B blood. That is the geometric. The first 9 are failures and the 10th one is a success. Part C, what's the probability? Exactly 2 of 20. That is a set number of donors, 20 donors, and a set number of successes. So that is binomial. So I am filling in the formula. I want exactly 2. Here is the binomial formula with 2 successes. So we have 18 failures. And then I go put that into the calculator. I guess I didn't show that binomial version, but that was 0.2822. Now we are collecting. Now this is an accumulation. So for at least 2 of the 10 are type B blood. So that's X is greater than or equal to 2. So my X is changing 2, 3, 4, 5, 6, 7, 8, 9, 10. So when you write this formula, put X's in because those are varying. Those are changing. And we're having them be greater than or equal to 2. So when I put this into Desmos, I put right greater than or equal to 2. And see, and I've changed my binomial distribution to be out of 10. All right, and so then next we've got this out of 150 seniors who donate blood. Then how many would you expect to have type B blood? Well, that's your binomial out of a set number of donors. Binomial mean formula is N times P. And binomial standard deviation formula is this right here. All right, and then the last one, you think there might be an unusually low amount of type B blood donors. How much would make you think 11% is a high estimate for East Parker County, meaning we have too low? So that would mean we got to get the outlier fence is 2 standard deviations below the mean. So I'm going to use this mean and this standard deviation. And I'm going to go down 2 standard deviations. So my fence is 8.86. So how many blood donors would alarm you and make you go, whoa, I think we've got a lot lower than 11%, and 11% is too high. That's number of donors, not an average, an exact number. So I need to go just outside the fence, just below that 8.86 is 8 type B blood donors, would make me suspect that we don't really have 11% type B blood donors in this area. All right, so that's it. So you can now practice, or there is an extra practice that you could do, unit 12 or day 12 extra practice if you would like, to make sure that you are prepared for the quiz on part 3. All right, so good luck to you on that.